Today is the second part of solving radical equations, and your essential question is, how do I solve an equation with radicals on both sides? So we're going to just kind of try a few examples of these. Now this one doesn't necessarily have radicals on both sides, but it does have variables on both sides. And it does have an extraneous solution, and we're going to talk about what that means in a minute. So to solve this for x, you want to cancel out the root. And so to cancel out the square root, we have to do the opposite, which would be to square both sides. Now, when I take x plus 1 squared, when you square something, that is multiplying it by itself. So we're not just going to square both of these. Because the plus is in the middle, you actually have to rewrite it as x plus 1 times x plus 1. And then on this side, the square and the square root cancel out, so we get 7x plus 15. Now on this side, we can double distribute. So x times x would be x squared. X times 1 would just be x. And if we distribute the 1, we get x and then plus 1. And then if we combine like terms on this side, we get x squared plus 2x plus 1 equals 7x plus 15. Now for this type of equation, since we have x squared in there, we're probably going to have to factor. So what I would suggest is to get everything to one side to set the equation equal to 0. So we're going to subtract 7x from both sides, and we're also going to subtract 15 from both sides to make it equal 0. So then we have x squared minus 5x minus 14 equals 0. So now what we can do is we can factor the right hand or the left hand side. So we need to find numbers that multiply to be negative 14, that add to be negative 5, and we could do 7 and 2, and the 7 would have to be negative, and the 2 would have to be positive. So if we multiply these together, we would get x squared minus 5x minus 14. So I just factored. So now, in order for this to equal 0, when we multiply two numbers together and the answer is 0, then that means one of these must equal 0. So I'm going to set both parts equal to 0 and solve it. So we would add 7 here and get x equals 7. And we would subtract 2 here, and so we get x equals negative 2. Sorry, so we have two solutions, and we're going to go ahead and check both of these solutions. Okay, so if I check x equals 7, I go back to my original equation. I have x plus 1, so 7 plus 1 equals the square root of 7x plus 15. So it's 7 times 7 plus 15. So this side equals 8, obviously. And then 7 times 7 is 49. And then 49 plus 15 would be 54. That's the square root. So obviously, if we work this out, it does not work out. And actually, I'm sorry, this should be 64, not 54. So the square root of 64 does equal 8, so actually this one does check out. Sorry. Then we have to check 2. So we have x plus 1. So we have, and actually it's negative 2, so negative 2 plus 1. So we're plugging in negative 2, and we have 7 times negative 2 plus 15. So then this side would equal negative 1, And then on this side, we get negative 14 plus 15, which equals 1. And obviously, the square root of 1 does not equal negative 1. So this one would be extraneous. So an extraneous solution is when you plug the number back in and you worked everything out right, but it doesn't check out. So the only solution to this equation would be x equals 7. X equals negative 2 would not be a solution. Okay? Now we're going to solve an equation with radicals on both sides. So we're going to, on this one, I have radicals on both sides, and I can't necessarily cancel out this negative 1 because then I would just be moving it to the other side, and it would still be outside the radical. So we're just going to square both sides. Now remember, I said when we're squaring something, that's like multiplying it by itself. So we have the square root of x plus 2 plus 1 times itself, the square root of x plus 2 plus 1. And then on this side, the square and the square root will cancel out because there's just one part. So we just get 3 minus x over here. Okay, now for this next part, it's just similar to the last problem. We're going to double distribute. So I'm taking this part, the square root of x plus 2, times itself. So that would be like the square root of x plus 2 squared. And then, hold on, right there. And then we have the square root of x plus 2 times 1. So that would just be the square root of x plus 2. And then we're going to distribute the 1. So then we would have 1 times the square root of x plus 2, which would just be that again. And then 1 times 1, which is 1. And then we still have 3 minus x over here. So if I have this squared, the square and the square root cancel each other out. So we just get x plus 2. And then right here I have one of these and one of these. So 1 plus 1 would be 2 of them. So plus 2 times the square root of x plus 2. And then plus 1 equals 3 minus x. So on this side, I have x plus 2 plus 2 times the square root of x plus 2 plus 1. So we're going to combine the 2 and the 1 together. So then 2 plus 1 is 3. So I get x plus 3 plus 2 times the square root of x plus 2 equals 3 minus x. So then if I subtract 3 from both sides, and these cancel out, and then I can subtract x from both sides. So these cancel out, and I have 2 times the square root of x plus 2 equals, and then this would be negative 2x. Now from here, I want to try to get the radical by itself again. So I'm going to cancel out this 2 in front. So to do that, I have to divide both sides by 2. So these cancel out, and I get the square root of x plus 2 equals, and then this would just be negative 1x. So then, to cancel out the radical, I have to square both sides. So the square and the square root cancel out, and I just get x plus 2. And then negative x times negative x would be positive x squared. And again, because I have an x squared involved, I want to try to get everything to one side and make it equal 0 so that I can factor. So I'm going to bring everything over to this side. So I'm going to subtract x and subtract 2 over to that side. That way the x squared is positive. So then I get 0 equals x squared minus x minus 2. So if I factor this, I'm finding factors of negative 2 that add to be negative 1. So right here I'm factoring. So factors of negative 2 that add to be negative 1 would be negative 2 and positive 1. So from here, in order for this to equal 0, one of these parts has to be equal to 0. So I'm going to make both parts equal 0 and then solve it. So I'm going to add 2 to this one, so x equals 2. And I'm going to subtract 1 from this one, so x equals negative 1. So those are my two solutions. Now I need to check to see if either of them are extraneous. So I'm going to check x equals 2 first. So if I go back to my original equation, I have the square root of x plus 2 plus 1. So the square root of 2 plus 2 plus 1 equals, and then I have the square root of 3 minus x. So the square root of 3 minus 2. So the square root of 2 plus 2 would be 4. So the square root of 4 plus 1 equals the square root of 3 minus 2, which is just 1. So this would be 2 plus 1 equals 1, which is not true. So this one is not a solution. Okay, it is extraneous. Okay, then I'm going to do the same thing, but I'm going to plug in negative 1. So I have negative 1 plus 2 plus 1 equals 3 minus negative 1. So then this would be the square root of 1 plus 1 equals the square root of 4. So this would be 1 plus 1, which equals 2, which does equal the square root of 4. So this one is the solution. X equals negative 1. So from here, you guys can stop the video and write your summary to answer the essential question. I do have one more example on here, so if you'd like to pause the video and try this next example on your own, you can try that. It's a little more complicated. So for this one, this is kind of similar to the first example that we did. We want to cancel out the root, so we're going to square both sides. So the square and the square root cancel out, and we get 10x plus 9 equals, and then this would be like x plus 3 times x plus 3. So when you square something, just remember it's like writing it out twice. So from here, we're going to double distribute this side. So we get 10x plus 9 equals, we have x times x is x squared. X times 3 is 3x. Then 3 times x is 3x. 3 times 3 is 9. So we combine the like terms on the right side, and we get x squared plus 6x plus 9. So from here, we can gather everything to one side so that we can factor it. So I'm going to subtract the 10x and the 9 over to the other side so that it equals 0. So we get x squared minus 4x, and then this would just be 0. So to factor from here, the only way to factor this, since it just has the two parts and there's no third term, we would have to take out the greatest common factor. So what would be the greatest common factor of these two terms? It would just be x, and then we'd be left with x minus 4. And again, for these two things multiplied together to equal 0, one of them has to equal 0. So we split them apart. So x equals 0 and x minus 4 equals 0. So we add 4 to this one, and we get x equals 4. So these are our two solutions right here. So we need to check to see if either of them are extraneous. So we're going to check over here. I'm going to check x equals 0 first. So we have the square root of 10 times 0 plus 9 equals 0 plus 3. So 10 times 0 is 0 plus 9. So we get the square root of 9 equals 3. That works. Okay, so 0 is a solution. Then we're going to check our second one. So we get the square root of 10 times 4 plus 9 equals 4 plus 3. So 10 times 4 is 40, plus 9 would be 49. So the square root of 49 equals 7. And that is true. So actually both of these are solutions and neither one of them are extraneous.